Hello everyone, welcome back to Amaze. In this video, we are going to start with chapter number 6, Triangles, wherein I am going to cover introduction to similar and congruent figures, and then we are going to see few important questions from exercise 6.1. So let's begin. So, similar figures and congruent figures, and from that you have already studied what do you mean by congruent figures in your previous grade, that is grade 9. So basically, let me take you through the congruent figures again. If I have two figures which are exactly the same, so basically all the angles are equal as well as all the sides are equal, okay, then we call it as congruent figures. Let me give you an example. Let's say if I have one rectangular size photo frame and if I make a copy of the same, then obviously the original one and the copy, if I will keep it together, then all the edges, all the corners will coincide to each other, right? That will be exactly same, okay? So that means both of them are congruent to each other, right? So if I go in depth with the definition of congruent figures, it says that it should have same shape as well as same size, right? So I am writing it here. For congruent figures, it should be same shape as well as same size. Okay. Now, what do you mean by similar figures? So, similar figures means it has same shape but not necessarily the same size. So, let me give you an example. Let's say the same thing. If I have one photo frame, okay, and if I am taking a copy of it which is the smaller size of that, okay, or else it is the enlarged size of the original photo frame, then you can say that both of them are similar to each other. So basically the shape will be same, rectangular size only, right? But here the change is there in size, right? Okay, so let me write down here. We have here same shape but not necessarily the same size, right? Now, so we understood congruent figures has same shape as well as size, right? But here in similar figures we have only same shape but not necessarily the same size, okay? So from this I can also conclude that all the congruent figures are similar to each other, but all the similar figures need not be congruent, right? Because if we have congruent figures, this is the condition, same shape, okay, which is already included in similar figures. So I can clearly define from here that all the congruent figures we can also call it as similar figures, right? But if we look at all the similar figures, okay, we can have same shape but not same size every time, right? So here we cannot say that all similar figures will be congruent, right? So again repeating the statement that all congruent figures are similar to each other, but all similar figures need not be congruent. Now, to get better understanding of this, let us take one example. So let's look at this example. So here we have two squares, okay, one is ABCD and one is PQRS. Now look at the length of the sides. It's 10 centimeter square here, similarly here 10 centimeter square. Now you can see all the angles are equal, okay, in both of the squares, and all the sides are also equal, okay, here also it is 10 each and here also 10 each. So that means we can say that ABCD square and PQRS square are congruent to each other as they are exactly the same. Okay, same in side lengths as well as same in angles, right? Now look at this two squares, blue one. Okay, so here the square EFGH has each side of 10 centimeter and it's a square, so obviously all the angles are 90 degree. Now look at the square IJKL. Here all the sides are of 5 centimeter. Okay, and all the angles obviously it is going to be 90. So now if we look at these two squares, okay, it seems like EFGH square has been diminished by a factor of 0.5, right? So it has been done just half of it because all the sides were of 10 centimeter. Now we have 5 centimeter sides, right? So it has just been halved, right? And we are getting this size. Okay, so now connect back to that example where I have given you an example of a photo frame. Okay, where I have taken a copy of the same with a different size. Okay, so here you can look at the different size, right? Okay, the sides has been just halved, right? So now this two squares EFGH and IJKL, we can call it as similar figures. Okay, now let's connect to the in-depth definition that we have seen, right? Same shape and same size. Yes, that is going it here. Okay, same shape, that is square, as well as the same size, that is 10 across. So congruent figures. And here you can see same shape. Yes, both are same shape, that is square here. Both are squares. Okay. Next is size. No, they are not same. So here the size is not same. Okay, so this we call it as similar figures. Okay, I hope you are clear with this example. Now let's see few conditions for a figure to be similar, for figures to be similar. Why? Because congruent figures you have already studied in grade 9. In this unit in grade 10, that is chapter number 6, triangles, we are going to see about similar figures. Okay, so I hope you are clear with the differentiation, with the difference between congruent figures and similar figures. So now let's look at few conditions about similar figures. So here we are having two polygons, or I can say quadrilaterals, right? ABCD and PQRS. So now let's go to specific conditions for two figures to be similar. So I can write down here two polygons will be similar if, what are the conditions? First one, all the angles should be equal, corresponding angles should be equal, right? So here I am writing corresponding angles to be equal, right? And the next condition is corresponding sides should be in same ratio, or I can say proportion, right? So what do you mean by this? These are the two conditions for any two figures to be similar. First condition is corresponding angles should be equal. So here you can look here, this angle B here, which is 45, okay, in the next figure angle Q is 45. Similarly C90, R90, D120, S120, A105, P105. So we can say here all the corresponding angles are equal, right? And what is the next condition? Corresponding sides should be in same ratio or equal ratio. So here you can look, side AB is 11, and here if you look at the corresponding side, which is PQ, it is 110. That is it is getting multiplied by 10, right? So now similarly it should be the case with all the corresponding sides. Okay, then and only then we can say that the second condition is also satisfied and these two figures are similar. So look here, BC is 15 and what is QR? It is 150. Again it is multiplying by 10. So here the ratio is 1 by 10, right? So you can take out the ratio also, 15 by 150, which is 1 by 10, right? CD is 4, RS is 40, again multiplied by 10, AD is 8, PS is 80, again multiplied by 10. So you need to look here that you are getting same ratio when you are taking the corresponding sides. Okay, let's say here you are getting multiplied by 10 and you are not getting multiplied by 10, then you will not conclude that they are similar figures. But for this particular polygons, they are similar figures because it is satisfying both the conditions, as all the corresponding angles are equal, okay, and the corresponding sides are in the same ratio, which is 1 by 10 in this case. Okay, I can write down here that 11 is the side of this and here it is 110, which is 1 by 10, okay, is equal to 15 upon 150, which is again 1 by 10. Okay, here 4 upon 40 and here 8 upon 80. I have written all of them equal because all of them gives the same ratio. Right? All of them are giving the same ratio. If we go into the simplified form, we are getting 1 by 10. So all of the ratios are equal, right? Then and only then we conclude that both of them are similar. So here quadrilateral ABCD is similar to quadrilateral PQRS. Clear? So these are the main conditions that you should be knowing for concluding two figures to be similar or not. Okay, now let's move on to important questions of exercise 6.1. Okay, so now important questions from exercise 6.1. So basically all the questions in 6.1 are objective type questions. Okay, so there is nothing such very important questions from exercise 6.1. Okay, but then too, let's see few important objective type questions. So the first important question is question number 1, filling the blanks, first one. So what is the question here? All circles are dash. So we have two options, congruent or similar. So all circles. Okay, so now obviously congruent means we have exactly the same circles, right? Then only we can consider it as congruent, right? Now here the question says all circles are congruent. We can clearly conclude here that all circles are not going to be congruent, because let's say if I have a 10 centimeter circle and I have a 10 centimeter radius circle and I have 5 centimeter radius circle, okay, like this, then obviously they are of different size. Obviously the shapes are same but the size are different. They are not going to be congruent. But if we look at the other option, similar, okay, so these two circles only, as you can see here. So the circle with radius 10 centimeter and the circle with radius 5 centimeter, here they are going to be similar because the shape is same and the size are different, okay, and the ratio is nothing but, if you consider 10 and 5, it is 2:1, right? So now here for the first one, the answer is similar, right? All circles will always be similar. Why all circles, not particular this example only? Because if you take any, let's say 8 centimeter circle, 8 centimeter radius circle and 3 centimeter radius circle, then also the ratio is 8:3. Okay, if you take out the ratio of the circumference also, you are going to get the same ratio, 8:3. Okay, the ratio of the radius is also 8:3, right? Okay, so all circles, obviously they are going to have the same shape, but it is not necessary that they are going to have same size. Okay, we can have different sizes, right? Now let's move on to the next important question, which is the third one. So what is given here? All dash triangles are similar. So now we have two options here, isosceles triangle and equilateral triangles, right? Now we have to identify which are similar, all isosceles triangles or all equilateral triangles. Now we know the condition here that in isosceles triangle we have two angles equal to each other, right? But in equilateral triangles we have all the angles as 60 degree, right? So obviously if we have two isosceles triangles, okay, let's say in one of the isosceles triangle the two angles equal are, let's say, 40 degree and 40 degree, okay, and the other isosceles triangle where I have two angles equal as, let's say, 80 degree, then obviously you can look here that they are not going to be similar because the angles of one triangle is not equal to the angles of the other triangle, right? Okay, so here for similarity the first condition is the corresponding angles should be equal, which will not be the case here, right? Next, if we look at the equilateral triangles, so if we take any two equilateral triangles of whatever the side lengths, the angles are going to be equal, that is nothing but 60 degree each, right? So if we take any two equilateral triangles, okay, the angles are going to be equal, so first condition is always going to be satisfied. Second condition is that corresponding sides should be in the same ratio. So let's say if I have two equilateral triangles, okay, one of side length 8 centimeter and one of side length 4 centimeter. All the sides are equal, right, in equilateral triangle. So 8, 8, 8 and 4, 4, 4. So if you take out the ratio, it is going to be same always because of the same sides in each triangle, right? So 8 by 4, which is 2 is to 1. 8 by 4, 2 is to 1 and 8 by 4, 2 is to 1. So corresponding sides have the same ratio, okay? If you take any two triangles, okay, I have taken 8, 4, you can take any like 10 and 3, so 10 is to 3 will be the ratio, okay, 10 centimeter side equilateral triangle and 3 centimeter side equilateral triangle. Again, the ratio will be 10 is to 3, 10 is to 3 and 10 is to 3, right? So here we can conclude that all equilateral triangles will have the same ratio and the angles are always going to be 60 degree, that means equal, right? So both the conditions are satisfying, so all equilateral triangles are similar. Okay, now the next important question or the objective type question is question number 3. So they have asked here, state whether following quadrilaterals are similar or not. So we are given here the following quadrilaterals and we have to state that they are similar or not. So for similarity we have seen two conditions, so let's see if both of them are satisfying or not. Otherwise, if not satisfying, we will state that it is not similar. So the first condition is corresponding angles should be equal. So here, as you can look here in the second quadrilateral ABCD, where we have all the angles as 90 degree. Okay, now look at PQRS. We have not been given angle, but according to the figure, it is clearly visible that it is not 90 degree. Okay, you can look at the angles formed there. It is not 90 degree, right? As you can see here, angle PQR, if you will see, it is more than 90 degree. Okay, as per the figure given, okay, it is forming an obtuse angle. Okay, so now from here the first condition is also only it is not satisfying, okay, because all the angles in the second one is 90 degree and here in the first one it is not equal to 90 degree. That means corresponding angles are not equal. Therefore we can say that the given quadrilaterals are not similar. Right? Okay, so that was it from exercise 6.1. Now in the next video I am going to cover similarity of triangles and then few theorems, important theorems based on the same, and at the last I am going to cover few important questions from exercise 6.2. So that's it for this video. Catch me up in the next video. Thank you.